Hello everyone and welcome to the second part of our webinar called IP Fundamentals for Pro AV Professionals. Thanks for joining again. We are glad to see you here, and we are glad to see that we didn't freeze your brain with the first part. Now it is time to dig a little bit deeper. While we wait for some more attendees to join, let me introduce Gábor Kocsis, but hopefully you saw him in the first part. He's our technical trainer, and he's been teaching IP for the past 20 years. So he has a lot of experience, and I think he's the best person to guide us through these IP fundamentals. A few housekeeping items. Depending on what type of device you're using, you can see Gábor's webcam and his shared screen next to each other or on top of each other, and you can manually resize one or the other to see it better. On smaller screens such as smartphones, you can swipe left and right to switch between the shared screen and the webcam. Secondly, since this is a webinar, all attendees are muted. You cannot unmute yourself, you cannot turn your webcam on, but you have a way of communication with the questions panel. So if you have any questions regarding any of the topics, or you have any kind of feedback, please use the questions panel and send us your feedback. And we will have some time at the end for a live Q&A. So I will read out the questions out loud, and Gábor is going to answer them. And lastly, I would like to assure everybody that this webinar is being recorded, and it will remain on our server or go to webinar server indefinitely. So you can watch it anytime in the future. However long this content is valid, we will keep it up there. And you will receive an automatic follow-up email 2 hours after this webinar ends. And that email is going to contain a link to the video recording. You can watch it, or you can send it, that link to your colleagues. If you would suggest to them to watch this video, then please do so using that link. So with all the technical stuff out of the way, let me pass the word over to Gábor. Gábor, the stage is yours.
Thank you, Tibor. So hello, everybody. Welcome to part 2 of a 5-part training series. And what we're going to do today is we're going to build on what we learned in part 1, and we're going to talk about something that's called DHCP, not to be confused with HDCP that we know from AV business. We're going to talk about something called Auto IP, a interesting functionality called Time to Live, or TTL. We're going to look into the technologies that we've probably seen in AV over IP products before, VLAN, multicasting, and link aggregation. At the end, I'm going to actually also add another functionality. It's called LLDP, which is a nice diagnostics feature. So a bit of a recap from first part. We learned on the building blocks of network communication about IP address, subnet mask, port number, and then we of course looked into how the network communication goes between private and public networks, and we looked into a little bit of what the OSI layer is, what those different layers do. And so we understand the basic concept how network packages build up, let's say, and how they travel over the network. Now, another reminder, of course, from part 1 is thanks to our high bandwidth that we use in our products, we really surf the waves of complexity on networks. So about 99% of all the complexity are done by the IT companies. They are the ones who have to run their products smoothly. So during this webinar series, we are going to actually stay above the waves, as we mentioned. And the complex stuff we don't really actually need to learn. We just need to understand what is relevant for our industry, and we look at the technologies and we understand how they actually function. Now, today's topics, as I mentioned, we're going to look into how IP addresses are created. We're going to look into this time to live functionality, and I will explain why it's important for part 3. And we're going to look into the VLAN functionality, multicasting, link aggregation, as I mentioned, the LLDP functionality. A reminder that in part 4 and 5, we're actually going to demonstrate the VLAN, the multicasting, and the link aggregation functionality. And we're actually going to use a layer 3 switch and something called the Wireshark network analyzer software. So you're going to see which functionality does what on the network and how it impacts AV over IP products. Now, first is we talked about all the IP addresses, and now we need to understand where they actually come from. There's actually 3 methods, I call it 4 different ways how we obtain an IP address, and I grouped them into 2 parts because of the way how we use them. The first, of course, is manual IP addresses when you enter these values manual in your computer or a Lightware device. And that's something that you've done before. And you've seen in part 1, we talked about how to do that and what kind of things we can look at in error messages if we do it wrong. Now, the other is something called the DHCP host-based communication, when we get an IP address dynamically. Somebody gives the IP address to us. And I grouped this actually with a functionality called a reserved IP address, when this DHCP host, this dynamic computer, can actually give us the same IP address. Now, this is actually used, these two methods are used when we, for example, use a TCP/IP command to communicate between two Lightware devices, the Lightware 3 protocol that we use fixed IP addresses. And that is important that those things actually remain the same, so the communication goes between those devices at all times. Now, the other two methods, actually, the third one is pretty much the same as the previous one. So we get the IP address dynamically from somebody, but we do get a random IP address. So that's something that the most common places you can see. And the fourth one is something called an auto IP address, which is a random number. And this is also linked to this dynamic method. But the concept is that if you don't have a computer that will give you an IP address, that's when you actually use it. Now, these are actually useful when the communication that you do is between a Lightware device and the LDC and the LDU software for communication and programming, and let's say firmware upgrading. We're going to see some examples how it helps us. Now let's look into one by one. And of course, the first one is manual IP address setup. Spent quite a lot of time on that one in the first part. And I mentioned it, conflict risk, because what happens is you enter the IP address, of course, in the computer, the subnet mask, something, the subnet gateway, the gateway IP address. And then what happens is this computer is going to go out on the network and it's going to start asking around. It's going to say, who has my IP address? Normally, we don't want an answer. However, if someone answers and someone comes back and say, hey, I have this IP address, then the system's going to generate an IP address conflict message. It's going to say, hey, somebody else is already using this IP address. But this is, of course, not a good thing for us, because now we're not going to be able to communicate, but at least we know that there is somebody with the same address. And this problem actually happens only with manual IP address settings. And actually, if you have, let's say, a system that has dynamically generated IP addresses, so the system generates the addresses, and this error comes up, that means at least one device is manually configured, because somebody is not following the rules that the system is giving it. Now, the other thing I mentioned is this dynamic host control protocol, the DHCP, and that means that a server computer, a router, typically a gateway, is giving us the IP address dynamically. Now, this is actually preferred by all the IT guys in large companies, actually in most companies, because the IP addresses, the computers, and everything that connects to the network can be actually controlled centrally. So they will decide who gets an address, who doesn't get an address, and who gets what. Now, this is when we, let's say, talk with an IT department and we request the same IP address. Then we don't ask them to give us a fixed manual IP address. We ask them to please give us the same IP address all times. And they're going to put it into a reservation table, and a reserved IP address will be assigned to the computer's MAC address. So whenever that computer or Lightware device connects to the network, this host computer is going to give it the same IP address. The other functionality is auto IP. Actually, Microsoft has its own acronym for that same functionality. And what happens is, let's say you enable your computer or a Lightware device in DHCP mode, so you're expecting somebody to give an IP address, but that device is not there, or it's not giving you an address. What happens is about a minute and a half later, the computer will actually stop asking and is going to figure out its own random IP address, which is going to be a 169.254 something number. And from part 1, you remember what /16 means. Now it's the 255.255.00 subnet mask. So first half of the IP address has to be the same, and the second half can be different. Now what happens is, if you have two computers, let's say a laptop with the LDC software and a Lightware device, have this function enabled, then they will actually get different addresses. But because of the subnet mask, they're actually going to belong in the same network. So now all you need to do is just to connect a piece of patch cable between the devices, and they're going to be communicating with each other. So technically, you can create a tiny one-on-one link local network without a network switch or a router. Now, here's an example. What I did is I set my laptop in dynamic mode or DHCP mode, and also the UBEX extender product. And all I did is I disconnected my router, and suddenly I have no IP address. So the 169.254 something something address came up in my laptop after a while with the 255.255.0.0 subnet mask. And after a while, the Lightware device, the UBEX, appeared in the LDC software also with this auto IP range. And when I went inside to configure, I could see that yes, inside the current IP address is, of course, the same, the 169.254 something something. So this is why it was important for us to understand the subnet masks and how they generated, because this is how two devices without any knowledge of who's around them can talk to each other. This is quite helpful when you want to go out to a site, you want to program an AV over IP product, and you don't have anybody to give you an IP address. You don't need to actually connect to the infrastructure, connect a piece of cable between the laptop and the network device, and it's going to be able to talk to you. Now, before we continue, I'd like to bring you your attention to something we have on our website, because we actually do quite a lot of research on technologies and compatible network switches. So we have two documents, they're application notes. One is for the Vinx and the other one is for the UBEX product portfolio. What you need to do, and this is actually quite useful for you to download as soon as possible so you can look into the details. So you go to our website, and there's a download section. And if you go to the download section, there's the download type window. And if you select application note and you enter network into the search bar, then you're going to actually find two documents. Now, these two documents are actually a Vinx and a UBEX kind of a configuration guide, a network switch guide. The Vinx is 7 pages currently, and the UBEX is 112 pages. You can find multiple network switches, compatible network switches, and we show you which functionalities need to be used, how to find them in the switch, and what to enable. So technically, we guide you the user interface of the network switch as well. Now, before we go into those advanced functionalities that we typically use, I'd like to mention something that is we're going to use actually a little bit in part 3. In part 1, we already talked a little bit about the ping functionality and the trace route, but there is something else we need to know because it's going to be quite useful to understand the different network behaviors. So the time to live functionality is actually designed so a network packet that travels from, let's say, the computer goes out to the internet, it does not just circle around the network if it doesn't find a destination somehow. So what happens is this packet that you're sending out, the network message, has an initial number, and every single time that packet travels through or hops through a routing device, a router, for example, then it's going to reduce this number. There are some notable exceptions to this rule, but we're not going to go into that. That's really in-depth network knowledge why a router would not actually change this number. Now, if you look at, let's say, a ping message and you have a response coming, and this is actually when you ping the lightware.com website or the cisco.com website, then you're going to see this TTL number. And this TTL number actually says that how many hops remain in the response message that you receive back from the destination. And that means that, for example, the cisco.com ping message has 236 more hops before it expires. Now, actually, we can play around with this. So what I did is the initial number actually can be changed. So I changed the initial number to 8 and then 9 because I knew from where I actually was looking at the Lightware.com server, 8 hops will not be enough to reach the computer. So technically, when the number becomes 0 somewhere on the network, when this TTL number gets lower and lower, it's the device that actually sees that it's becoming 0. It's going to send a message back to us and say, sorry, your packet expired on the network. We're no longer sending it anywhere further because it's been spending too much time on the network. Now, once I changed that number to 9, what happened is I got the response from the server and I got the different address, so a different number. So the 9 hops that I set into my ping command, the -I9, means that I want to reach that computer within 9 hops, maximum 9 hops. And when I got the response back, it says TTL 57, because that is how many hops remain in the response before it expires. We are going to use this functionality. I'm going to give you some tricks how to use that and find out how the internet really operates and what's internet reliability is. Now, before we, of course, leave this functionality, I want to make sure that we do not confuse this functionality with another function that we actually require in our network switches to be enabled this spanning tree protocol, or STP. They're both designed to reduce the unnecessary traffic in the network. However, TTL is designed so a packet that is routed way too far does not just circle around the internet, while STP is designed to have the same package, not to have the same package circle around in multiple switches and keep back in a loop. So technically, we're going to look into both functionalities, but TTL is by default in every packet, and the STP functionality is something we need to enable. Of course, as I mentioned in part 3, we're going to actually see how the TTL functionality can help us a little bit to understand more about networking. Okay, but now we're actually reaching the area where we have those advanced functionalities, the ones that we actually document in our application notes. And what you're going to see is how those features actually operate, what they actually do for us. And of course, the first is something that you've heard before, the VLAN or virtual LAN functionality. So let's see what that does for us. Now, VLAN is like, let's say you work in an office or work in a group of people, and you're not physically in the same office. You're not sitting next to each other. Now, you have to somehow communicate with each other, but you have to make sure that you don't use something very complex and it's efficient. The communication is fast and reliable. Now, of course, you cannot just walk over to the other person's desk. You would typically do a video call right now with a lot of home office situation. The other thing, of course, what you don't want to do is you don't want to bother others with your communication, and you also don't want anybody else to bother you. So imagine when you go into a meeting room with your colleagues in the office, that's what you pretty much do. You get close to each other, you talk to each other, but you don't want anyone else to bother you. That's why you're not talking in an open office. You go into a meeting room. So this is what you prefer for an efficient communication. Now, if we look at the network environment in this case, technically, if you want to do the same thing, what you need to do is treat the computers that are not really close to you like they were your neighbors. They're really sitting next to you. So you need to somehow feel like you are connected to the same network switch, even though you are not. Of course, there are certain technologies that do this layer 2 protocol, which we're going to talk about a little bit in part 3, and you need to make sure that those are possible. For example, the LDC discovery protocol to find the LDC devices. Of course, you don't want to feel the speed going down, you don't want it to be slow. And of course, you don't want to do any disturbance. You don't want to get any disturbance from anybody else. If you don't care about their message, you don't want to see them. This is actually what VLAN will bring you in general. It actually helps you communicate with other computers efficiently and isolate yourself or isolate your small network from everybody else in the infrastructure. Now, before we continue, I want to make sure that there's one visualization is clear. When I use this cloud that I call wide area network with the number of routers inside, that cloud does not equal the internet. So a lot of places when you see a cloud representing a larger network, many times they represent the internet. We put a globe inside so we clarify what's the difference. So the WAN can be a corporate wide area network. Now, there's a note actually in previous trainings we had questions coming up about VLANs through the internet. That's a lot more complicated subject than is possible, but the internet service provider needs to give you special support to actually create that. So it's not something that you can really do on your own, just enable it and function like a local network. So that's not, those two clouds are not the same. Okay, so let's see how this actually feels and looks like. So this is how it feels like what's happening when you're on a virtual LAN. So you've got 6 computers next to each other. But this is actually what's really happening. You are connected to certain network devices to specific ports, and those ports are connected to other devices, and there's this cloud and some more devices with the laptops or computers connecting to it. Now, this is actually what it looks like, what's happening. So you do have switches and routers in a real VLAN. You have this larger wide area network, and there are remote computers. This is actually the core functionality why the VLAN was really generated or developed, to bring devices far away from each other into a closed network and not to have a lot of complexities and slowdowns. Now, with this, let's clarify that the VLAN is actually an infrastructure setup. And the physical ports on these network switches, or physical devices, if you will, are allocated into this logical group, the numeric logical group. And that's how they are differentiated from each other. Now, depending on the needs, depending on what you actually want to use the system for, we have two general types of VLANs. One is called the untagged, and the other one is called the tagged VLAN. There are some other types, but that's below the waves of complexity, so we're not going to talk about those right now. We're going to look into these two. Now, well, if you have this network that I've shown, and all of these computers are actually connected to the same virtual LAN, then you don't need to use something called a tag, which we're going to talk about in the next slide. So this is when I connect all these devices to the same network, and I say this is untagged. So what happens is the network switches will allocate the ports on the switches to the same logical number, and the network is going to actually work. Well, in a simple terms, this is what, in general, this functionality does. Now, if you actually have, let's say, a server computer that has to be in multiple VLANs, then we have the functionality, and that's when we need that tag. The tag is actually a kind of a numeric identifier, a little label that gets placed in the IP header. And this is actually so you can differentiate network packets from each other. Now, let's see where is it important. So if I have, let's say, these 4 computers or 3 computers are talking to the 4th one, the server, they are in one VLAN, the VLAN 1 or the blue VLAN, if you will. But if you have the other one, which is green, then now you have to identify the network packets that are on the same wire but belong to 2 different networks. So wherever the cable between, or the line between the switches and routers is both green and blue, on those lines you must be able to differentiate if a network packet is coming from VLAN 1 or VLAN 2. And the entire path, wherever there's 2 different VLANs communication is going, must be tagged, so the identifier separates the packets from each other. This is actually what tagging does in general. Now, actually, VLANs have multiple rules and special functionalities, but for us in AV over IP, in the beginning, actually, we need to only, well, remember kind of 2 things. One is that untagged VLAN is for devices, let's say devices on one switch or like multiple switches in the local area. And tagged VLAN is used for trunks and switch ports, something they call switch ports, when you have multiple VLANs. And stay tuned for part 5, because we do something specific with the tagged VLAN functionality in UBEX to enhance our performance. Now, in order to show you this example, I turned on the multiple VLANs on the network switch, and I intentionally clicked untagged for the same switch in multiple VLANs. And of course, the switch says, nope, it's not possible. You are, in this case, I have specified the same port untagged as multiple VLANs. So this says, nope, untagged only works if you use one VLAN. So this is how the switches actually help us. In certain user interfaces, they don't even let you select untagged once another VLAN's, the same port in another VLAN has already been untagged. Now, let's see how does it affect us in real life. So imagine you're sitting next to Lightware devices on the same switch, but in the LDC software, it's empty. You don't see the devices. So what happens is, even though you're physically sitting next to each other, you're not in the same VLAN, because the physical port that you're connected, your computer, is on a different virtual network. So technically what happens is the broadcast messages that are used between the LDC software and the Lightware products are not sent to your computer, because that's what VLAN does. It separates networks. So if you have a different VLAN, the other VLAN's traffic is not going to come to you. So it's not a problem. It's actually expected behavior. So what you see, if you see this, that's the first thing to look at is, am I in the same VLAN with the Wings or not? Now, the other subject actually is multicasting. It's a bit more in-depth what we look into, but we're not going to go really deep on that subject. So first and foremost, there are 4 general ways we say we're communicating on the network. One is, you heard about broadcast before, that is when I send a message to everybody on the network, and I don't care who they are. This is something that hubs used to do, and all the switches actually do. And this is pretty much a vital functionality in networking. A lot of messages, a lot of information that make the network work are actually broadcast messages. The other thing is unicast. Now, this is something that you do a lot when you do, like, let's say, go to the internet, you talk to a web server. So you get one-to-one network communication. So from one source to only one destination. Switches and routers do this, of course. And then we got multicast, which is somewhere in between when we have one source, but we have more than one destinations, but not everybody. And this is when we need some advanced knowledge in the network switches to do this kind of functionality. And the fourth, I mentioned in passing, the routing, when we communicate between networks, and this is something that routers do. This is something we're going to talk about in part 3 when we look into the differences between managed switches, unmanaged switches, and routers. Now let's see, why do we even need this multicast functionality? So imagine that you have one single source to, let's say, do video streams, and you have 3 computers that would like to see that video stream. Now, in a normal system, when you don't have this functionality, you would have 3 computers building an individual communication link with the source, and that would be 3 different unicast communications. So from the source to 3 different destinations. And that means that the bandwidth use of the source computer is tripled. Now imagine if there's 4th or 5th computer comes up, and that network communication link between the switch and the source is saturated, you're no longer going to be able to send the messages to the additional computers. So you overload one side of the network. This is actually when multicast helps us. Because what happens is the single source, our computer, sends the message to a network switch, not to the recipients. And somehow the network switch knows which recipient's supposed to receive the message, or the packet, or the video stream, and it actually multiplies the data. And it's the switch that sends the message to the recipients. Now, okay, so let's see what happens if I have a switch that does not support this functionality. So if I have this computer, let's say, that sends the message, and it knows what multicast is, it sends a message to a group, not a specific address. But the switch does not understand this group address thing, so it's going to say, I can't drop it. I don't know who it belongs to. I'm going to broadcast it to everybody, and whoever wants to have it, they can have it. And this is actually when the issue comes up, because everybody will get it on the network. That's what broadcast does. And if in this particular case there are 2 computers who don't care about this, they will receive the video stream, and that video stream is going to actually occupy part of their bandwidth. So they're going to get maybe network slowdowns. They will download things slower because somebody's sending them unnecessary high bandwidth data. Now, if the switch actually supports multicast, then what happens is when this group address is being, let's say, pinged by the source, and the source sends a video stream, now this group address will be understood by the switch. And the switch actually maintains a list. And it looks up the list, and it says who wants to be part of this group, who's the one who wants to receive anything that comes to this group address. And it's going to only send to those who want to. That means they are subscribed to the group. And the other 2 who are not subscribed to the group, they will not receive this particular stream. Now, let's talk about how it's done. And this is actually something that called the IGMP, the Internet Group Management Protocol. And there are 2 major technologies that we need to understand. One is called snooping, and the other one is called query. Now, snooping is typically done by network switches, and the query is actually done by something called multicast routers. And actually, higher end layer 3 network switches can do this. They are compatible with this functionality. Now, before we continue, just to note that IGMP is actually an IPv4 specific technology. IPv6, which we don't use yet, have different technologies to do the same. So let's see first the IGMP snooping. So what happens is when traffic goes on the network switch, the switch, as I mentioned, it maintains a special list. It's actually a list of MAC addresses, and it's going to look at the MAC addresses of computers that are subscribing to a specific group. Now, some of these MAC addresses are actually special because they don't represent a computer. In part 1, you remember we talked about MAC addresses. They are kind of serial numbers burned into computers. Well, these ones are special. So then what happens is that the message that is going to this multicast group will be sent to the computers with the MAC address that are in this particular table. Now, the other functionality is the IGMP query. So what happens is if there is a router or a advanced network switch in this particular infrastructure that is capable of doing this query, it's going to go out and it's going to ask a question, just who wants to be part of what group? And then the devices, the computers, the Lightware devices will respond to this device and say, I'm going to subscribe to this and that group. So just pretty much announce all their subscriptions or join statuses. And based on this response, actually, this router is going to maintain a list of IP addresses and MAC addresses. So this is actually needed because a network switch with the IGMP snooping works on the switch level. So it would not work between two switches, but somehow we have to make that work. So this IGMP query functioning server, gateway, router, whoever does that, is going to make sure that the process, the entire IGMP process and the group numbers actually work across multiple network switches. This is how we want to make sure that let's say a Vinx or a Ubex product can talk to another device in the same group, even though they're physical and not on the same switch. Now let's see a bit of an example. I mentioned, of course, that these MAC addresses and IP addresses are special. Well, for example, if what I try to do is I ping those addresses for you, and 224.0.0.1 as a specific IP address. And of course, the computer said, yeah, it's a failure of, you cannot do that. And the other one, and you're going to see this later, the 224.0.0.251, I pinged it, which is also a special IP address. It did not come back with a failure, but it timed out because the computer knows this address, but these are not real computers. So there are no physical MAC addresses sitting behind it. There are no devices come back and say, hey, this is me. Now let's see how we use this technology in our products. So let's see real applications in AV products. So for example, the Vinx devices have a dip switch to select the video stream. And if this dip switch is 0, then you can actually do the same video stream selection with a software control, so inside the LDC software. Now let's see, for example, that I set this video stream to address 17. So what happens is if you look at the screen and you look at these numbers, they all become 017. So it's going to be 017 in this multicast group IP address. It's going to be actually the IGMP protocol content. It's going to be a message with something 017 ending IP addresses. And also the MAC address will end with 0011. Now 11 hexadecimal is 17 decimal. So that 17 video stream ID has changed its IP address and the MAC address of a packet that goes into this group. Now, what I did is I actually changed a couple of things for you to visualize it. So if you look into the first half of the multicast group IP address, then you see an interesting number scheme. And this is actually something for advanced users because you can change those numbers, but you really need to know what you change and why. Now, for this training, I did actually change the default 225.2 first half of this IP address to 2262 and then 2264 to demonstrate that this can be changed and what happens. So the video stream ID remains 17, but when I change this to 2262, then the third number, of course, in this IP address is 2. So you can see that in the IP addresses that are 2, and also in the MAC address, the third block from the left side, so the third octet from the left also became 02. Now, if I change this to 4, the same thing happens. I can change that, and in that case, the IP address changes from 2262 to 2264, both in the IP header, also in the content says I'd like to join the 4017 group, and it also changes in the MAC address. And this is actually how layer 2 and layer 3 devices recognize this detail, because what happens is the very specific first half of a MAC address, the 01005E, is called an IPv4 multicast MAC address block. And any device that looks into it from that part knows, yeah, it's a multicast group. It's not a real computer. And then the rest of the MAC address is actually created from the IP address, the second, third, and fourth octet. And that is exactly why a 4017 IP address part is becoming 40 and 11, which is 17. Now, here's the list of group addresses that a computer actually subscribed to. This is my laptop, and a number of these groups typically are joined by a computer by default by static modes. And these are actually, many of them have specific meanings. It's called in the INA standard, they define what those IP addresses have to mean and what those IP addresses have to do when someone wants to communicate to it. So This is actually the same thing with our AV over IP products. We do subscribe to these groups, and we also subscribe to other groups. For example, our video stream multicast group, which I mentioned the 070 in the previous example. So these are the IP addresses that are specific. Now you see 224.225.239, something like that. There's a specific range that can be or should be only used for multicast. And the IP address and the MAC address relation is the same. So when I look at this block, every MAC address, even though the IP address ranges are different, they are 0100 and 5E. That means that they are an IPv4 multicast MAC address. And when you look at numbers in the other part, you see 02 is 02, 0252 is 0FC, which is hexadecimal for 252. And if you have, let's say, the other one is 03, then you have that particular 03. Now, if we go back to the example of sitting next to Lightware devices, and we're sitting on the same switch, now we change the VLAN setting. So now we are in the same network, but the LED is flashing way too fast. What happens is when we're in the same VLAN and we can see the products in LDC, then we get the communication and broadcast. However, most likely the IGMP setting is not set properly, so every multicast message that I don't want to see actually comes to me. I want to get the broadcast messages, not the multicast messages. And since advanced and managed switches actually can turn on and off this functionality in every individual port, it's enough if you actually turn off or accidentally don't turn on this feature on one port that is transmitting a lot of multicast information, and it can actually flood the other ports. So if you do this and your computer gets a little slower and the LED flashes way too quickly, then the first thing you look at is, okay, VLAN is fine, I see the devices, but somebody's sending me stuff that I don't want to see. Now, let's see how we actually make use of this functionality even further. Let's say we configure the encoders and the decoders. Now, we've got this dip switch, but what happens is when you open LDC, the software actually shows all the available devices that it can discover. And if you're in encoder view, you can see all the available decoders. Now, next to the product, next to the decoder, will be a gray or a green box with the checkbox. This means that that device is on the same video stream ID, so in the same multicast group or not. And actually what you can do is if one of these devices is gray, you can select it and the decoder will automatically leave its old group, whichever group it was in, and it's going to join the group that the encoder is set to. On the other side, when you're in the decoder, you can also see if you have multiple encoders on the network. And there's a radio button because you cannot select multiple encoders, but you can actually get to select which one of the encoders video stream you want to subscribe to. And you can see once you select in the radio button one of the encoders, your stream ID will actually change. And that's actually is quite a useful thing. If you have multiple decoders, you can select them and all the decoders can suddenly get to one encoders. And if you have multiple encoders, you can select which one you want to follow. Now, we of course have something called the unicast mode, and this does not support this functionality. This is a unicast functionality. So we actually still make use of the multicast group IP addresses. We're going to talk to it just for a short while until we get the other end to talk to us. So the moment we find out that there is a decoder, let's say I'm an encoder and I find a decoder in the group, I'm going to start talking to it directly on its IP address. So, and that's what unicast does. It's not going to show you the list of devices. Now, the dip switches, of course, don't have any impact on this because they select the video stream. Now, if you want to look at how this actually affects you, if you have a Wings pair in unicast mode, then the only way you can find out if you are actually talking on the same port is suddenly at some time the video signal next to this block is going to show up and say, yes, I have video signal and I can see the sample. With the multicast mode, then you would actually see the list of devices. You can click, you can see that they become green, and then a few seconds later, you're going to see the video signal also coming. So that's actually when you can see with the multicast mode that you have set the decoder to your video stream ID, and then it takes a couple of seconds until the device leaves the old group, joins the new one, and starts receiving the video stream. Now, before we move on to further functionalities, let's do a little bit of a summary, because these are two technologies. So actually VLAN and IGMP, in the network performance, it has a similar feel and similar response, if you will. So the IGMP actually filters multicast, and the VLAN filters everything. So if you have, let's say, a network switch that only has Lightware devices, then you're not going to actually see a difference. If you lose the products in the LDC software, that's, as I mentioned, the expected behavior. That's what VLAN is actually supposed to do. However, we actually recommend using both functionalities, because when IGMP filters multicast and VLAN filters broadcast, unicast, whatever unwanted traffic, it takes some time to set up a VLAN properly. It's not that difficult, but of course in large system it can be tricky. But using both, what's going to happen is the VLAN is going to separate you from everybody else, and the IGMP is going to keep the VLAN clean inside, because you can have multiple groups in the same VLAN, and the IGMP is going to take care of it and is going to make sure that, let's say, video stream 1 data is not going to video stream 2 data. Now, two more functionalities I want to talk about. One is something we're going to show you in more detail in part 5. It's link aggregation, when you connect more than one cables in parallel. And what you do is actually, if you follow the application notes, there are a few simple steps. You can enable the link aggregation functionality. And when you enable it in, let's say, I'm going to show you a network switch user interface. If you enable it, it's going to pretty much turn on the default functionalities, and they're going to actually make the system work. What's really going to happen in this case, the UBEX products require this over a certain bandwidth. And what's going to do is it's going to actually split the SFP plus connection into two network connections, and is going to balance the data on those two cables. This is how we actually get 18 gigabit per second, for example, in two 10 gigabit connections. Now, if you simply enable on the, let's say, simple user interface, you enable the LAG, which is link aggregation group, then this label is going to actually make the system work. And there's only one functionality that we need to turn off. It's not really bothering us, but it's unnecessary to be turned on. And as I mentioned, you're going to actually see live when I'm turning on and off this functionality, and see how this is actually going to affect our product. And there's one more functionality I wanted to show you, which is actually optional in our application notes. So you don't have to enable this, but I do recommend this to be enabled, especially on larger networks, because this is a very nice functionality. It's optional because it's actually not going to impact our performance. It helps you with stuff, because the LLDP is called a link layer discovery protocol. What it does, it adds text information coming from your network neighbors. So the network switch, for example, or a UBEX product will have more information to share with everybody else. So if you go to the application note, it says turn on everything. So just click on everything, turn it on, and you're going to have very nice benefits on the diagnostics process. Let's see how it looks like. So if I turn on the LLDP, then in, let's say, the LDC software, when you go into the MMU product, which is the matrix management unit, which controls the UBEX products and when they are networking, then in the LLDP section, instead of the NA or not available part, you're going to have text information. For example, you're going to see the network name, the text name of the network switch you're connected to. And it also shows you the number of the network switch port where that particular UBEX product is connected to. Now think about the benefit of having, let's say, 20 or 30 UBEX products with two large connections, let's say 2 times 10 gigabit. Then it's quite a useful thing for you to know which switch connects to which UBEX and on which physical port, because you're going to have a lot of DAC cables or fiber optics cable connections to find. Now, this of course works both ways, because if you go into the network switch, then there is this LLDP device, typically called remote device summary list. And in that list, you can see similar things, but you can actually see the UBEX product's name, the type coming up, and it's going to also show you two different IDs. One is called the chassis ID, which is the UBEX itself, the MAC address of the device itself. And since the UBEX has two SFP plus ports that you can communicate, it's going to also give you the port ID. So imagine you have a large system and you are the network administrator. You can see this list. You can copy paste it to any software, let's say Excel, and you can create a network map information table for yourself. So when you want to troubleshoot, you know who's there and what's their MAC address. So using two softwares, you can troubleshoot a fairly large network cabling quite easily. And with this, we reach the end for our today's topics. And let's see if you have any questions. So I'd like to give the controls back to Tibor.
Thank you, Gabor. Those were quite interesting topics. We don't have any questions yet, although we have quite a big group today. So I think you have shocked everyone, as with the first part. Well, more than the first part. I think we went more in depth, and we are going to go even deeper in the third part. So if you have any questions, feel free to let us know today. I think many of you have played around with fixed IPs or with DHCP settings. Some topics you might not have played around with, especially link aggregation if you have never used UBEX before or you haven't connected switches to each other. So hopefully we could show you something new, and the topics were interesting enough. I see some thank you messages coming in. So this is usually the time when people start thinking about, can I ask something or not? So they were probably keeping close attention. And we got feedback that it's a lot of information to digest. We know. We try to cut it up into these 40-50 minute parts so that it's still digestible. But as I mentioned, the recording will be available. You will get an email 2 hours from now from GoToWebinar server, and you can watch it again in case we went too fast in certain parts or you want to check again. How long will the recordings be available? Indefinitely. So as long as we decide that this content is still relevant. If we do an update, then we will of course make new webinars, and then the new recording will take this one's place. But until we do that, it's going to be on GoToWebinar server, and you can use that link. Oh, we have a long question from Ignacio. Let's suppose you have a small LAN with some audio or video devices and nothing else. I'm thinking of Dante network or NDI network. Do you still recommend setting up a VLAN?
If you have a dedicated switch and you don't really have anybody else, so there's not going to be different networks and there's nothing to protect from, you don't really need to use a VLAN. So the one thing that we recommend is the IGMP setting. So if you have, let's say, one or two groups, then you separate from each other. But if there is nobody else around you, it's not needed to protect yourself from somebody else. The only case would be if somebody would accidentally connected to that switch, so it's not protected. They connected to accidentally and they start broadcasting messages, then suddenly you would see unnecessary information. That would be the only reason, but by the standard performance, a single switch with only our devices, it would not be necessary.
Okay, thank you.
Just a note, please stay tuned for part 5 because we use a very specific reason for a tagged VLAN for UBEX.
Okay, next question. Will current Lightware AV over IP products support ST2110 standard traffic as they take hold in the market?
We need to look into that particular standard and talk with the engineers and come back to you on that. So we're going to note that question and we're going to go into the details with the specialists.
Okay, I'm just scrolling through. Thank you guys, thank you. Amazing knowledge. All right, also from Ignacio, what about having internet in the same switch as your LAN? What configuration would you recommend?
Well, if you have internet on the same switch, immediately turn on VLAN. Of course, the IGMP snooping is still needed to keep it clean, but you need to separate yourself completely. And if it's a multiple purpose switch, it's a higher level switch, then you talk to the IT guys and you make sure that the VLANs are not having a so-called bridge functionality in between them. So there's no way that internet communication can go somehow and impact your VLAN. In part 3, we're going to talk about different networks and why internet is important to note and why we want to separate ourselves from it.
Okay. If any questions come up while we wrap up, then I'll interrupt myself and come back to it. If no more questions are asked, then thank you very much for joining us today as well. I hope this part was also interesting and interesting enough to see you in the third part and the fourth and the fifth, of course, which are going to be about Wings and UBEX. If you have any questions after this webinar ends, then please feel free to send it to your local Lightware representative or send it to support@lightware.com. Or if you want to ask something from Gabor, then please send your question to training@lightware.com. Gabor sees those emails and he's going to respond. So if you would like to request a demo, I know we haven't shown you Wings or UBEX devices. Those are going to be in the fourth and fifth part. But if you would like to receive a demo unit to try out for yourself, then also reach out to your Lightware representative and we can absolutely make that happen. Some people learn while they get their hands on these devices. And unfortunately, these days, we cannot organize any demos in our offices or we cannot organize demos in your offices, but we can certainly send you demo devices, help you to set them up and play around. So even in this situation, you can try out our devices. Okay, Ignacio wrote something else. Sorry for repeating himself. He's not sure he understood about link aggregation. Could you please repeat the concept real quickly, link aggregation?
Yeah, so link aggregation is when I have too much data for one cable and I'm going to split it to multiple cables. So when I have, let's say, an 18 gigabits per second to send between two UBEXs, then I'm going to have only two 10 gigabit connections. So link aggregation will actually combine those two cables into 20 gigabits of bandwidth so I can send over the 18 gigabits. It will split the data between cables and it will balance the data between those two cables to make sure that everything reaches the other end.
Okay, really helpful. Thank you. All right, so one final thing. When the broadcast ends, you will be prompted to fill out a survey. I think it's 5 short questions. We would really appreciate your feedback about this webinar, what was interesting for you, how you would like to improve this webinar. So we are always looking for ways to improve our materials or the way we deliver these materials. So please let us know your thoughts. We would really appreciate them. Okay, one more question. Does a lag act as a failover for any data under the 20 gigabits?
Well, failover actually is a different concept that's part of the trunking. That would not be part of it. So typically, if you have a lag, and I'm going to actually show you what happens if a link aggregation group is not, let's say, big enough. What happens is the system is going to recognize that one of the links is down and the other one is not enough. So in that case, since you have two cables, if one of them fails, then the other device is not going to actually take over because the two connections are not enough. If you have that failover situation that's typical between multiple switches, then you would have to set up multiple connections, a larger link aggregation group, a trunk between switches, and that's where you would add the multiple cables that if one fails, the other ones take over. That's a in-depth, more advanced network setup. But individually in the UBEX products, for example, when you have only two cables, you have to make sure that they both function because there will be no failover.
Okay, thank you. Okay, no more questions. We finished 5 minutes early, so hopefully you enjoyed it. Thank you again for joining. Thank you, Gabor, for doing this presentation, and hopefully see you in the third part. Bye.
Thank you. Bye.